Hi, I am Kevin Wiebe, the Engineering Manager for General Energy Recovery. I have been working with GERI for the past 3 years developing our direct contact steam generation technology. DCSG technology combines steam and all the flue gases into one stream and injects them into the reservoir. We know that steam is useful for improving oil production, and we know that non-condensable gas injection, nitrogen, and carbon dioxide is also useful for improving oil production. Field studies and literature have shown that by combining these three products together and injecting them simultaneously improves oil production significantly more than by injecting them individually. In a conventional steam generator, as shown on the left, all the combustion gases are directed into the atmosphere. This is a significant amount of wasted heat and tons of carbon dioxide that is pumped into the atmosphere. The main difference between that and in the DCSG as shown on the right is that all of these combustion products now go down into the reservoir. There are no emissions in this process. GERI's process can either be run off of grid power or from electrical generators. The power is for the two main compressors, air and fuel, which deliver high pressure air and natural gas to the DCSG. These two products are then mixed and combusted, and the heat generated from it is captured by the water, which turns to steam and then is sent to the reservoir. Here is an overview of the equipment on a typical lease. You can see in the top electrical generators, then we have the air compressor building off to the left. The E-house controls everything, and then on the right we have the fuel gas compressor, and on the bottom left is where the DCSG is put in a pressure vessel. Everything is then sent to the wellbore. Some of the key benefits of the DCSG technology is that there is a large reduction in oil viscosity and a significant improvement in relative perm to oil and gas through the heating effect. Because all the flue gases are being sent downhole, the reservoir is being repressurized by nitrogen and the sequestration of carbon dioxide. Additionally, in the process equation, for every mole of methane being combusted, 2 moles of water are being created, thus reducing your freshwater demand by as much as 13%. In a typical CSS operation, a SOR of about 3 is considered excellent. A study of Pikes Peak completed by GERI in combination with SRC showed a steam-oil ratio of less than 1 is viable even after 10 cycles of injection. To date, GERI has steamed 4 wells in the Lloydminster area, and we have successfully increased our power from 4.5 gigajoules per hour up to 8.6 gigajoules per hour. In addition, our steam quality has gone from 65% up to as high as 84%. Much of the carbon dioxide that we inject also appears to stay in the reservoir. When the well was put back on production, we noticed only about 30% of the CO2 was produced back. This is a huge environmental win. There are likely many applications for DCSG technology. Heavy oil is probably the largest application, but SAGD and CSS are also excellent candidates as well. GERI can also steam non-thermal wells using our patent-pending annular cooling loop. We set a packer near the reservoir and inject steam down the vacuum-insulated tubing. Water is then pumped down a coiled tubing string to the packer and produced back up the annulus. We have done this on 4 wells to date, and it works very well. The advantages of a portable direct contact steam generator is that it is much less expensive to deploy than a large steam plant. And the steam requirements are approximately 1/4 than that of a one-screw steam generator to achieve a similar oil production rate because of the non-condensable gases being injected simultaneously. There are many government funds available to increase your oil production from your reservoir using direct contact steam generation technology. CRIN, NRCan, and ERA, just to name a few. If you want more information, please visit our website at geri.ca, or you can reach out to one of the contacts listed here. Thank you very much.